Open Open-FinLLMs with all of you. And first, I'm gonna to start from introduction. And recently, like large language models is rapidly transforming the financial sector. The chart on the left shows how technology investment priorities shift by company size. So you can see here on the left lane, the company size is from 250 to 999, and the second lane is from 1,000 to almost 10,000, and the third lane is 10,000 and more. Notably, the focus on AI and machine learning, which is the orange line here, increases significantly as company size grows, indicating that large language models are becoming core capabilities for larger firms. And the right side is the enterprise CTO of Microsoft. He also thinks that the financial institutions of all sizes are actively exploring AI applications, even under some strict regulatory environments. So overall, the trend reflects how large language models are driving both innovation and operational efficiency in finance. And despite the importance, the finance services sector has been relatively slow in adopting generative AI tools. So, as shown on the left, compared to industries like legal and media, the financial sector has the lowest adoption rate of generative AI in both 2023 and 2024. According to some FinOS survey on the right side, 39% of respondents think that the main reason is due to the limited in-house expertise, and 40% thinks there is a lack of data and legacy technology. So these findings suggest that while interest in generative AI is growing, capability gaps and institutional barriers are holding back its full potential in finance. Mm, but even if companies were fully ready, we still face another challenge. Does these models themselves fully prepared for the financial domain? So there is some actual evaluation results of existing large language models in financial tasks. We can see that even the most powerful GPT-4 model here only achieve less than 40% of score of average score in across all the financial tasks. And for other models, the performance range from 20 to 40. So all the models perform relatively poor in financial domain. So next question is how to improve large language models in financial applications. So there are three main uh, like methods. The first one is pre-training from scratch. So the advantage might be that we could fully enhance large language model with domain knowledge, but and it is quite slow and high cost. It is hard to follow up with like general domain models. Um, and the second method is to do some instruction tuning. So its advantage is it is fast, cheap, and it could adapt it with downstream tasks, has strong instruction following abilities. However, the instruction tuning might need a lot of human annotated high quality data set. And the third one is continual pre-training. Well, compared with the previous two methods, it is not as cost as the pre-training from scratch, and it do not actually require a lot of instruction to the data. So here is some of the existing work in like developing financial large language models. The first one is Bloomberg GPT, which is pre-training from scratch. The second one is FinTrial, which use continual pre-training. The third might be Pixel and FinGPT, which is using instruction tuning. From this chart, we can see that there are some limitations of this existing work. The first one is they have relatively limited domain-specific corpora. The second one might be they all focus on text-only dataset, which they have make them have limited multimodal capabilities, which is important for financial domain. The third one is they have limited evaluation scenarios. from the right side, we can see that our work, including all the five uh, like evaluation settings compared with the previous work. So to bridge these gaps in our work, we introduced Open-FinLLMs, a novel open financial large language model family. We focus on four key points. The first is domain-specific continual pre-training. To teach this one aims to teach the model more financial language information. The second one is instruction tuning. We use over 500K financial instructions to align model behavior with real use cases. The third one is we do some multimodal extension, since all the financial data includes not just text, but also tables, charts, and more. And finally, uh, we do some comprehensive evaluation across 5 real-world scenarios and over 19 task types. Here is the overall framework of our work, detailing how we build domain-ready large language models for finance through 3 stages. The first is continual pre-training, the second is fine-tuning, and the third one is evaluation. We start by the continual pre-training by collecting 52 billion tokens of high quality financial text and including 18 billion general domain tokens. After that, we get FinLlama, which is a foundation financial model. And this step enables the backbone to learn more financial domain knowledge by feeding more like domain specific data. Then we perform instruction tuning. We with 573K financial instructions result in FinLlama instruct. The This step improve financial FinLlama's abilities to follow different instructions. And to further enable multimodal understanding, we collect over 1 million image text pairs and align them with a clip encoder to build the third model, FinLlama, the vision language model. At last, we test these 3 models across a broad use cases, including zero shot, few shot, some trading environments, and some instruction follow tasks, also including some multimodal tasks. So next, I will introduce more details of these models. Uh, I will start by the continual pre-training step. Like compared with all existing work, a key factor behind the strength of our model lies in the quality and diversity of the financial data we used for pre-training. For example, the Bloomberg GPT uses massive web scale data, which is almost 300 billion web tokens, but lacks financial documents such as conference calls or indicators. Uh, while the trial focuses more on small-scale structured data, which is only 20 billion tokens in total. In contrast, our model uses 52 billion tokens of domain-specific high-quality financial content, covering a wide range of sources. And in addition to the financial data, we further mix uh, 18 billion, 16 billion general domain data. This step makes sure that the model do not forget general knowledge, which is also important in financial domain. And here are some details of how we train the model. Uh, this provides the technical details of the continual pre-training. We follow the standard next token prediction objective with like this loss function, and we set up the learning rate as 1e minus 5, and the apple is set to 1, and some other parameters like weight decay and warm-up ratio and batch size is also listed here. So the training was conducted over 250 hours on 64 A100 GPUs, allowing us to effectively adapt the model to financial language, context, and structure without overfitting. This process turns a general purpose like a Llama 3 which is served as the backbone of our model, into a financial domain specialist, the FinLlama. So after FinLlama, we further do some instruction tuning to get FinLlama instructor, where we optimize the model for domain-specific tasks using curated financial instruction dataset. So here is a comparison of instruction dataset between FinTrial and FinLlama Instruct. Where both models use some shared sources, we further include more like 177K instruction dataset. At last, we use over 500K, which is more than 2 sizes larger than the FinTrial. This expanded dataset allows our model to better align with realistic financial use instructions, improving performance in question answering, document summarization, and some financial reasoning tasks. Here we outline how we train the FinLlama Instruct using some LoRa-based instruction tuning, which enables efficient adaptation of FinLlama with minimal computational cost. So here is some also settings of the model training. Well, compared with the previous continuous pre-training step, this instruction fine-tuning step was relatively more efficient with using only 6 hours of 8A100, well compared with 200 over 200 hours over 62 A100. The instruction tuning step is very training computational efficiency. Beyond the text, many financial tasks involve like images, charts, or tables. So we further extend our model to handle multimodal inputs through developing FinLlama. Similarly, we start by collecting training dataset, including 2 main categories. The first is like multimodal alignment dataset. The second is supervised fine-tuning dataset. So which in total we collect over 1 million pair data. The first stage is used to align image features with text through caption tasks. So here, clip is used as some image encoder here in our framework to extract representations from financial images such as charts and tables. And these are passed through a 2-layer MLP projector to align with text space by mapping the image embeddings into the text embedding space. We use FinLlama as the backbone model here, allowing seamless text-image fusion. Then, fine-tuning data is used to improve the model's abilities to follow image text instructions as seen in financial QA or chart-based reasoning. This equips FinLlama to handle complex document layouts, financial diagrams, and visually grounded instructions, essential for like real-world financial AI. Here, all the model, all the components in red are can be used for training. All the parameters are used for training, and all the green part are used some frozen parameters. This is the training detail of FinLlama. We use over 600K samples for image text alignment and over 800K samples for supervised instruction tuning. And here is some details of the training hyperparameters. The entire training was conducted on just 8 H200 H20 GPUs for 60 hours. And next, we do a comprehensive evaluation to investigate how well does this Open-FinLLM families perform in financial tasks. We first evaluated the performance of FinLlama through 3 evaluation settings: zero shot, few shot, and some like trading settings. So in the first zero shot setting, we use 19 dataset covering 9 tasks, including some general tasks like sentiment analysis, classification, question answering, as well as some financial tasks like misinformation detection, fraud detection, and some math reasoning. We compare our model with some strong baselines like Llama 3, 8 billion, Llama 3.18 billion, and the financial model Bloomberg GPT. And from the zero-shot results here, we can see that our model outperform all other models in most of the datasets, especially compared with Bloomberg GPT, uh, which have larger size and was trained on larger dataset. It consistently underperformed our FinLlama model. This further shows that the high quality of curated data that used in our work. Also, our model outperformed its backbone model, shows the effectiveness of domain adaptation for financial tasks. And here is some results of few shot setting. Here's some like datasets of few shot setting. 4 datasets are used in this setting, including tasks like sentiment analysis, classification, and name identity recognition. And we use the same baseline models as the previous one. Similarly, our model consistently outperform all baseline models. And in addition to these traditional like uh, evaluation settings, we further use the trading setting to evaluate the performance of FinLlama. So this actually we use a framework of some previous work, FinMan, which is an agent framework designed to do some trading tasks. We use the daily market news, some company 10K reports, and the daily stock price as input information sources, and let the model to handle it, to process it, and do some memorization of history data, and to do some decision making with buy or sell the current like assets. So we use FinLlama and other models as uh, at the core of this agent system and evaluate the performance of different models. And here is the results of the different large language models. We can see that FinLlama also get some quite good performance out of all the different assets. And here is the details of the performance of every model in each month. Next, we evaluated the performance of FinLlama instructor. For a fair comparison, we only compared with instruction fine-tuned models here, including Mistral 70 billion instruct, as well as financial domain model like FinTrial and FinMa. We also include some powerful closed source models like GPT-4 and ChatGPT here. Here is a summarization of the instruction learning performance of FinLlama across 6 benchmark tasks. Scores range from 0 to 1. So our model FinLlama Instruct achieves the highest performance in 3 out of 6 tasks. With it should be noted that we only have 8 billion parameters. With this parameter, our model could even outperform the powerful closed source GPT models that have much more parameters and train on more data set, more data. Also, our model outperformed FinTrial. This further improved that the training data and the methods we used in our work is very powerful. Beyond instruction learning, we also evaluate our multimodal model FinLava on visual reasoning benchmarks, especially those relevant to finance. Uh, this slide outlines the dataset and baseline used to evaluate the FinLlama's performance. Uh, we include 2 existing datasets, the above two, MMMU and MMMU business. In addition to these datasets, we further contribute 2 datasets, chart bench and table bench in our work. And we, in addition to the previous models, we further include a more powerful model like GPT-4o and Gemini in the evaluation setting. This is the result of all kinds of models. Our model outperform all other models in one of out of 3 datasets. it should be noted that GPT-4 all outperform other models in all other three data sets. And if we compare the performance of only the open source models, we can see that FinLava, which is our model, outperform all other open source models with similar parameters or even 13 billion parameters. And for the table bench, we even outperform the GPT-4o model. Here is some more like case study to show how FinLava handles complex financial tables and charts. So the first case would be some table understanding task, and the second one would be some chart understanding task. We can see that our model could like accurately get the key information from this table and the charts and answer the questions. Now we've seen how well our model perform across task and multimodal tasks. Next is some discussion about how we could use the Open-FinLLM models effectively in real-world financial workflows. We mainly consider the three key usage modes. The first is the serve as foundation model. They can be used as initialization for supervised learning, fine-tuned or private or on firm or some firm-specific downstream tasks, such as trading data, such as trading client chat logs, and for the instructing tune models, they are ready for zero shot or few shot prompting, which can be used directly on different like task specific scenarios, such as document classification, extraction, or some reasoning tasks. And for the multimodal FinLava, we could support chart table and scan image understanding. And these models are suitable for use in AI assistance, audit, automation, and report generation, or some compliance workflows. Uh, uh, while OpenFinLLMs offer flexibility and strong performance, they are not without limitations. So first of all, they are not fully open. Since our models are based on Meta's Llama series, they inherent the non-commercial licensing restrictions. While the weights are available, they may limit downstream commercialization or redistributions. And the second one is we only use some kind of outdated information. Despite our recent dataset, large language models are frozen at the time of training. For fast evolving financial contexts, such as Fed policy changes, models may lack up-to-date knowledge without retrieval or continual pre-training, continual updating. The third one might be some limited decision-making capabilities. Large language models are good at reasoning, but still struggle with some sequential decision-making, such as like trading simulations, multi-term financial planning, and so future work could also combine large language models with agents or planning modules to improve their performance in this kind of scenarios. The last one might be the deployment complexity. With even at 8 billion parameters, which is a relatively small as a large language model, GPU deployment remains costly. Memory containerization and inference optimization, such as VLM and use some int4 technologies, are still required for on-premise use in banks or fintechs. So here's the conclusion. In our work, we developed three large language model: FinLama, FinLama Instruct, and FinLava, designed for financial tasks. And we do some comprehensive evaluation of our models, and we can see that with our high quality curated financial data set, our model consistently perform all other models with similar size or even more powerful models in financial tasks, which highlight the effectiveness of continual pre-training, instruction tuning, and some like multimodal alignment task methods. And That's all. That's basically all for today's sharing. Thank you for your attention. And we have released the model's datasets in our Hugging Face. Please feel free to visit and leave any comments. Uh, Thank you.